Hi guys, this is a supplementary video on adding vectors. So our first vector is going to be 10 meters going east and 15 meters going 20 degrees east of north, which roughly looks like this. Next, we're going to try to find RV, which is the resultant vector. To be able to find the resultant vector, first we need to find the resultant in x and the resultant in y. If you can see now, we have formed a right triangle. So if that's the case, we know that RV squared equals RX squared plus RY squared due to the Pythagorean theorem. So how do we find RX? To find Rx, we need to find d1x, which in this case is 10.0, and we need to find d2x, which is this part. Since we don't know it, we're going to calculate it in the next step. But before that, let's see how we calculate Ry, and Ry is d1y, which in this case, since d1y only travels east, there's no north or south contribution, that's going to be 0, and then we're going to add d2y, which is this part. Okay, next we are going to try to figure out d1x, d2x, d1y, and d2y. So to do that, let's take our first vector, which is 10.0 meters going east. So from there, we know that d1x is going to be equal to 10.0 meters. And since there's no contribution up or down, d1y is going to be equal to 0. Now let's draw our second vector, which is 15 meters going 20 degrees east of north. So to get that, we need to find d2y and d2x. And again, we formed a 90-degree triangle with a 20-degree angle in between them. So if we're trying to find d2x first, we can see from our right triangle that that is the opposite side of the 20-degree angle. So the trigonometric function that relates opposite and hypotenuse is going to be sine. So the sine of 20 is equal to d2x over 15. So from there we can solve that d2x equals 15 sine of 20. So now we will use our calculator. So d2x equals 5.13 meters. Now to find d2y. d2y is the adjacent side of the 20-degree angle, and the trigonometric function that relates adjacent and hypotenuse is the cosine. So the cosine of 20 is going to be equal to d2y over 15. So we will solve for d2y, and that's going to be 15 cosine of 20. Again, we use our calculators, so d2y is going to be equal to 14.09 meters. So now we have d1x, d1y, d2x, and d2y. So let's use that in the formula we just had before to solve for Rx and Ry. So d1x is equal to 10, d2x is equal to 5.13, and when added together they are 15.13 meters. Now d1y is equal to 0 and d2y is equal to 14.09. So together they are 14.09. So let's use the formula that we have for RV squared, and we know that RV is going to be equal to the square root of Rx squared plus Ry squared. which in this case happens to be 15.13 squared plus 14.09 squared, which is going to be 20.7995 meters. And if we use the correct sig figs, we notice that our first vector is 10.0 meters, so that's 3 sig figs, and then we have 15.0 meters, and that's 3 sig figs again, and then we have 20.0, which is 2 sig figs. Since we're supposed to use the smallest sig figs, we are going to round this up to 2 sig figs, which is going to be 21 meters. Now we need to find theta, which is right there. And theta can be found with, if you see in there, we have Ry and Rx. Ry happens to be the opposite side of theta, and Rx happens to be the adjacent. So the trigonometric ratio that relates opposite and adjacent is tangent. So the tangent of theta equals Ry over Rx. So to find theta, that equals the arctangent or the inverse tangent of Ry over Rx. So we'll just put our numbers in our calculator, and theta is going to be equal to 42.96 degrees, and with sig figs that's 43. So having these data, the angle and the RV, now we know that the resultant vector is going to be a vector going 21 meters, 43 degrees north of east. Okay, and that's it. Hope it helps. Good luck. Bye.